Travel graph part 1. Now on a travel graph for distance time graph, distance is measured up the vertical y-axis and time along the horizontal x-axis. We have the distance in kilometers and the time of day on the x-axis. Each square represents 15 minutes. So the graph here tells this story. First of all, John set off for a cycle ride at 9 a.m. His speed was 12 km per hour. So on the graph, this is represented as an increasing straight line. Now, after half an hour, he had a puncture. It took 15 minutes to repair. So at 9:30, he had a puncture and another 15 minutes to repair the puncture, represented by a horizontal straight line. He continued on his journey up a hill at 5 km per hour. So at 9:45, from 9:45 to 10:45. So what we want to do here is get the line of the 5 km per hour. So what we do is 6 plus 5, it's on the 11, and 10:45 the time because we said kilometer per hour. So this is the line that we get, an increasing straight line. At 11 a.m. he returned home without stopping, arriving back at 12:45 p.m. So this was represented by a decreasing straight line because he didn't stop and he had a constant acceleration. His approximate speed home was 7 km per hour. We had talked about this graph in the previous tutorial. Here the increasing straight lines show that the velocity was increasing, and the steeper the slope, the faster the speed. So the line in the orange is faster than the one in the blue. A flat section indicates that the time you are stationary, like the 15 minutes that he stopped to fix the puncture. Slope in a distance time graph equals the average speed of a moving object. So if you want to get the speed, we should get the area under the graph. Let's start with the first part. It has a triangular shape. We convert the 30 minutes into seconds, into hours by dividing over 60. So the slope is equal to 6 kilometers over 0.5, which is equal to 12 kilometers per hour. Now, if you want to get the slope of this part, we have here 5 kilometers, on the x-axis 1 hour,